previous video, we looked at polymorphism as the last of the three tenets of object-oriented programming, and how we could use inheritance, like we learned about yesterday, as a means of implementing the print method on multiple types, and then polymorphically calling that print method regardless of the derived type. Whether it was a book or an automobile, we were able to call print, and it all worked. Since the base class supported it, each derived class can then override it. But then we asked, what if we don't want to supply an implementation for the print method in the base class? What if we just want to require that a derived class implements print, but we don't want to force a specific implementation? Well, the answer just might be abstract classes. An abstract class is just like a regular class, except that it can define methods, or rather method headers, without defining the body of those method headers, which forces all derived classes to implement that method, in this case the print method, without the base class implementing its own version on its own. Okay, so if you take a look, I have a new project called Polymorphism via Abstract Class. And take a look specifically at the product.cs class. Here you can see that I'm using a keyword here, abstract class product. And then again, I'm using that abstract word in the print method. Public abstract void print. So now if we go to our automobile class, you can see nothing's changed here. We still have the override method, the override modifier to our print method. And the same would be true for our book class as well. And nothing has changed with how we actually derive from a base class. We've simply added in our product the abstract keyword, both in the class and in the method itself. Okay, so let's take a look at the program.cs. Alrighty, so here, this is going to look very similar. We're going to still work with a generic list, so a list of product. Here we're going to add items, or create two items. Here I'm going to need to actually add them. So let's go inventory.add A1, inventory.add B1. Great. And so now we're going to be able to polymorphically call the print method. And we can see that this indeed works. Awesome. Okay, so now we've seen two methods of implementing polymorphism into our applications. The first was with simple inheritance and regular classes. And in the second, we're using abstract classes. Abstract meaning that I'm not going to, as the parent class, I'm not going to define the implementation. I'm going to rely on all of those that derive the class to agree that you're going to implement this print method. And it's up to you how you want to implement it. Okay, so that's really just the nuance between the two. So both of those methods, whether we use simple inheritance or we use abstract classes, they both required inheritance. But what if it really doesn't make sense for all the classes in your application to be inherited from a common base class? It happens to work now because in our simple example, both automobile and book are both of type product. But what if I didn't want them both to be related to product? What if they were so different in nature that they really didn't need to be in that hierarchy, all part of the product base class? Can you still work with classes that are not in the same hierarchy, but still work with them polymorphically? And the answer is absolutely yes, you can. And in the next video, we're going to explore the important topic of interfaces. So we'll see you in the next video. Thank you.